Welcome to Qt Widgets and more. In today's episode, I will go back to a cliffhanger, namely in the previous episode where we saw headers span multiple columns, I told you, and then you need to connect some signals. And which signal was that? I'll look at that. But this episode is truly much more about class design than anything else, so stay tuned. No, I didn't get lice in between the last recording and this. It's just to indicate that this episode is much more about scratching an itch. How do I design a class to minimize code reuse? And the class that we're talking about is what you see here on the screen. So remember from a previous episode, there's a link just below, that I have this table view here or tree view over there with some headers that span all the columns. And the way that I implement that was using this setup row spans, and you can go and check that episode on what exactly was it doing. But the key thing in this episode was the comment that you see here. You need to listen to relevant signals from QAbstract item model and call setup spans, say model reset, rows inserted, etc. I didn't bother in that episode to go into details, but let's just look at it again here, and let's try and add a row. And you can see it worked out well. Whenever you need somebody, is that a Depeche Mode song? I don't think so. Anyway, I can also add a header row, and oh yeah, Rick Astley, there he is again. But it's not highlighted as a header row. You can see the background indicate that it's a header row, but it isn't spanned as a header row. I can also call force reset, and now you can see there is no row set up anymore. So I need to listen to some signals. Adding rows doesn't seem to. The view will itself listen to signals from the underlying model and update whenever you add rows. But those specific things it will not do. And of course, it will also listen to remove rows. So let's look at which signal we need to connect to. And the class that I'm designing here, I would like that to be your drop-in replacements for QTableView and QTreeView all over your code bases. So there shouldn't be any overhead relating to spanning of headers if a specific table or tree do not need that facility anyway. But on the other hand, you shouldn't be going way out of bound to solve the problem. If you sometimes need it, it should be as easy as saying, well, now I want it, and now my model will actually provide the information. So the code that we look at now here in step number 1 is a Qtable with inline headers that is simply a subclass of QTableView. And as you can see down here, it has this msupport row span, which is false by default. So if you do not have that on, then it's just a regular QTableView. It overrides set model. As we will see, that's important because you might change your model on your table multiple times. And if you change the model, then of course, it should listen to that new model. It implements two methods here, connect span signals and disconnect span signals, which is how it'll listen to the underlying model for changes that might make it need to update the row spans, either for the table or for the tree. In this case here, it's of course the table. Yeah, you did see that warning from Clazy, huh? Well, let me just give you 2 hints here. First of all, do turn the Clazy warnings on. There's an episode for that. And also, do remember those Q_object. It's a bad me that I didn't have it, and there's a link to an episode that tells you why that is a good idea. So let's look at the implementation of the code here. First of all, we have the setup row span method, which is exactly what we saw before. So that hasn't changed anything. What has changed is that I have these 2 methods, connect span signals and disconnect span signals, that will, as the name indicate, connect and disconnect from a number of signals. And you can see I'm connecting from the model itself. So I'm listening to the model underneath me. When it tells me, hey, I was just reset, then I will call on myself, that's this part here, I will call setup row span to reset up that row span. Which signals am I listening to? Well, model reset, rows inserted, rows removed. So I'm listening to all of those after the fact signal. So I'm not listening to rows about to be inserted because I don't have anything to do beforehand. It's just when it's done, I want to be notified so I can update the the model or the representation of those row spans. Do I need to listen to all of those? Well, let's postpone that discussion for just a second. Let's go up and look at what does the rest of the setup here looks like. So first of all, I have this method setModel, which you very well hopefully know from your views. That is how you tell your view, this is the model that you should be listening to. And again, remember, you can actually change models on the fly. So I need to see if I'm actually changing models. So if I am supporting this row span, see, if I don't, then I won't do anything. If I am supporting row span in this particular view and I have a model set, because I could set the model to be null pointer, meaning remove the model again, then I will disconnect span signals. So if I didn't have a model set already, then, or if I did have a model set already, sorry, then I will disconnect the row span signals on the old model. Then I'll tell the table view, hey, here's the new model. And then if my model is actually, so if it's not remove any model here, but if there is a model and I do support, then I'll connect. The set row spans enabled method is the one that will turn it on. And that one, you could have had it enabled, disabled, I didn't bother with that. But you can see it sets it here. And if I do have a model, then connect the signals. So it do actually support that I can connect it both before and after having set the model on the view. And that's about it. I call the connect span signals, and doing so, I actually call setup row span, so I get the initial setup of the row span. Let's have a look at QTreeView with headers. It looks oddly familiar. This code here is different from what we just saw, but it's not different from the original setup. But it's different from what we saw simply because tables and trees look slightly different API-wise when it comes to that. Look at the old episode for a discussion on that. But the connecting to the signals, the disconnecting from the signals, the setting the model and setting row span is exactly the same. And that is the next itch that I'll start having a look at. But before we get there, let me just show you that the code actually works now. So here is it running again, and you can see if I add a row, there won't be any spans, and add header row, you can see it spans all across here. And force reset will now correctly call that setup row span method again. And for that to work out, we had all of these signals here. Let's just discuss, do we need them all? Well, the model reset, surely we need that. Whenever the model says, okay, I give up, consider nothing ever I've told you is correct anymore, we start from scratch, then of course I need to set up those row spans again. Rows inserted, well, not with regular rows, but with header rows, but how would the view know if it's a regular row or not? Well, in that situation, I also need that. Rows removed, I likely don't need that one, because whenever you remove a row, the row span information will go away for that particular row, and that's cool because all the others works just fine. And so on and so on. So you can go and argue with yourself just for the full reference, because I likely myself will go and find this code here eventually and just copy and paste all those signals for another setup eventually. For that reason it's there, but for your own purpose, go and look at them if you really need them and play a bit with it. So back to the problem with the code duplication. We saw that there was, with the QTableView with inline headers and QTreeView with inline headers, there was a lot of code duplication. And my initial instinct to that was, well, I'll put it into a superclass that both of them subclass from, and doing so will solve all my problem. And other instinct might have said, well, let me put it into a helper class, but then I would need to call upon the helper class for anything there. So likely the superclass is a better idea. So let's look at what that code looks like. It's surprisingly complex, and I'll of course help you along explaining why it is so throughout the code. So looking at the API here of the QTableView with inline headers, I'm subclassing from QTableView as always, and I'm subclassing from this new class RowSpanHelper, and the only thing that I need to implement is this this pure virtual method from the RowSpanHelper, namely the setup RowSpans. And I also need to implement setModel. And it looks like this. Whoops, doesn't look like this. Qt Creator gets slightly confused whenever I'm jumping and have the same name throughout all of the place. It looks like this. There we are. So here's my RowSpan setModel. And you can see all it does that it simply calls up to the superclass QTableView. Here's your setModel, and to the RowSpanHelper setModel up there. And besides that, everything is the same. It is not 100% perfect from a client's point of view, but one method that you need to implement besides the actual thing, that is okay. However, let me take you to RowSpanHelper class. So it looks like this. There is an inner class. I'll tell you in a minute why we need that. I have my RowSpanHelper here, which again, forgot the Q_up. No, it's something else. Never mind. So I have my RowSpanHelper and a destructor for that. Here's a setModel method, the one that tells it, this is a model that you need to listen to. And remember, my RowSpanHelper is not subclassing from QTableView or QTreeView. So it can't be just going to the view. I could, I guess, have given it the set view, but then it would have been the same thing on the client code. Namely, I would need to call a method on the RowSpanHelper class to notify about the model. This is the pure virtual method that I need to override in both cases. And then there is some implementation details, the connects and disconnects as you expected, and the supported RowSpan method that we saw before. And well, I have this inner class that I need to. So let's go over and look at what do we need. So looking at the connects, the setModel, that's where the things get interesting. So setModel says, if you support RowSpan and there is a model, well, we saw that before, right? Then disconnect, set the model and connect. Okay, so far, easy peasy. The set RowSpan, the same thing as before. Okay, so it's down in the connect method that it gets interesting. So what do I want to connect? I want to listen to the model underneath, that's m_model, for all of these different signals. And I want to call this method, the virtual method that we had here, setup RowSpans, in action to that. So I actually, don't tell anybody, I actually went ahead and just wrote this code here, and then this, comma, and myself, comma, inner. And my compiler complained, sorry, I cannot connect to a slot that is on a class that isn't subclassing from QObjects. Oh yeah, you're right. It needs to subclass from QObject for the slot to be able to connect to. So therefore, I needed to subclass from QObject. So my next attempt, no, I didn't do that. I'm way too used to working with Qt, but my next attempt could have been to go and subclass from RowSpan or subclass RowSpanHelper from QObject. But had I done that, I will tell you that C++ would have told me you're subclassing from QObject here and you're subclassing from QObject there. No, that doesn't work out well. So what I needed to do was a small trick that you'll find numerous places inside of Qt. Namely, I'll create an inner QObject that the API outside doesn't know about. And that inner QObject is exactly what you see up here, RowSpanHelper inner QObject. And if we go over and look at my RowSpanHelper setup over here, my inner QObject is subclassing from QObject. It only knows about the RowSpanHelper. The setup rows is just calling upon this original, the outer class setup rows. And this is a QObject subclass, so I can connect to this method here as a slot. And that's exactly what we do down here. I'm just getting my inner, which is a unique pointer, get that QObject pointer there, and I connect to that. And I disconnect down here, and let me just scroll up through the whole class. That is really everything that I needed. So I took the superclass now and put it, or I created this RowSpanHelper, made that a superclass that I subclass from for both my table and my view setup. And here is all the code that is sitting there together. Lovely. Yeah, that was when it started itching, and now you're itching too, aren't you? Sorry about that. Namely, I had this one method that I needed to call in client code. I really hate when I have that because sometimes I'll forget. Okay, I admit, it is difficult to come up with more than 3 classes for this. QTableView, QHeaderView, and QListView. And QListView, well, there isn't really a concept of multiple columns, so there's not going to be any span. So it's only QTable and QTree, but still it felt a bit like, do I need that? Can I do better than that? And also I really disliked that inner model. Could it go out of, or inner Q object with the model, could that go out of sync with the views model? Well, I don't think so, but still was a bit annoying. So I wanted to do better. And that was when it struck me, how about instead of subclassing from this one, how about I make it into a template? So I subclass from the template, and it's a template on the view, either QTableView or QTreeView. Confused? You won't be after this bit of code. So QTreeView with inline headers, now subclass from RowSpanHelper. That is actually a templerized class that takes the QTreeView as a template. And let's go over and look at RowSpanHelper to understand what it does with that tree view. Well, it subclasses from it. So now, previously I had QTreeView, RowSpanHelper, TreeView with headers, whatever it was called. Now I have QTreeView, RowSpanHelper, headers with whatever class. And that allows me to override methods from the tree view, because I'm a subclass now here, I being RowSpanHelper. Nifty little trick, but let me show you the true value in this. If we go back over to the class here, observe the line 32.5 is no longer. There is no longer this set model that needs to tell the tree view and the RowSpanHelper. Of course, now I'm subclassing, so I can override the set model. That's what we'll look at first here. So my set model method here is now overriding the set model from the tree view or the table view, and it does exactly that as it's done before, but this time it can go straight to the model of my base class, namely the QTreeView or the table view, and override that one. Set rows enabled is exactly the same as before. And finally, my connect span signals is again a QObject connect. Actually, it doesn't need to be QObject : anymore. I should have removed that, but you can cope with that. It will connect from the model. Again, going to the superclass, is there a model set on this view? And well, better be when I'm down this code here. It'll take that model and it'll connect the model reset, and it'll connect it to a slot in this. That's this column we have here. So again, now there is not any problem with an inner object, because my Q object is the one from Q, or the one that QTableView or QTreeView is subclassing from. And the signal that the slot that I'm connecting to is RowSpanHelper setup RowSpan, which is this virtual method, which therefore is the one implemented in QTableView with inline headers or QTreeView with inline headers. Pretty nice, isn't it? I think they crawled all over me now. I started itching because now I have this beautiful solution. I love it very much, but the template header file was filled with code that didn't have anything to do with base, the template parameter, namely disconnect and connects. Could I move them into the C++ file? Both yes and no. What I can do is one of two tricks, and I'll show you both. So the first one is I'll subclass my header, helper, whatever it was called class. I'll subclass that one from a private one that do not have anything to do with the template, and those methods can be put in. Let me show you the code. So I have my RowSpanHelper base. That was what it's called. My RowSpanHelper base is the superclass of RowSpanHelper. So my RowSpanHelper is both subclassing from base and from RowSpanHelper base. And the method that doesn't have anything to do with this template, namely base here, they will go up here. This one given that there's no templerized stuff on that one, can of course have its implementation in the CPP file. So therefore, my RowSpanHelper base connects span signals and disconnects span signals now go into that C++ file, as does the must support RowSpans here. And sorry, I was just, what is this about? That's new, isn't it? The connections here. Well, let's head over to the C++ file to see what that is all about. But at least for now, observe that the templerized part where I actually show the implementation has now boiled down to just these two methods here. So let's go over and look at the RowSpanHelper base implementation here. Over here, I have my connect span signals and I have my disconnect, and they look somewhat different now. And the reason for that is, let's go back over there. My RowSpanHelper base do not subclass QObject again. So therefore, I cannot implement slots on this one here. And I don't know about the subclass at this stage, obviously. So what I need to do is that I need to give the model in and the receiver. So the receiver, as we'll see over here in the connects, the receiver is this, namely myself. And I need to give the model in because, well, I don't have access to base : model. So I give the model and I give the receiver in. I do set up the connection as before here, connect from this model, all of these slots onto the receiver and onto wrapper. Well, wrapper, that's just a lambda connection that we have up here. And why do I need the lambda connection? Well, what would I write over here? That would be somewhat difficult too. I don't know the class of receiver at the time of writing this. So instead, I use a lambda connection for the connection over here. The wrapper simply calls setup RowSpans on myself, and setup RowSpans is this pure virtual method that we already have up in the base implementation here. Disconnects. Only way I can disconnect from a connection to a lambda expression is by actually taking the return type of connect, which is an identifier for that particular connection, and disconnecting that. And that's what we'll do. I'll remember each of these connections in m_connections, and my disconnect, then I'll simply run through each of those connection IDs here, and I'll call disconnect on them. And of course, I'll clear my connection so I don't get that list being filled up with more and more stale connections. I'll not try and scratch myself because rumors has it that that makes the audio max out. So it did bother me a bit that I now had to give this additional information of this and model over because I had the superclass that didn't subclass from QObject and where I couldn't call methods on the subclass and all of this stuff. And I was like, can't I just take those methods and put them into the C++ file and write enough template, blah, 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 in there to tell it that it's still a template? And well, I admit, I'm not that strong when it comes to template programming, but I did remember I saw that like 15 years ago in some code bases, and I looked very carefully and I found a solution that I actually think is better than the previous one. That was my initial solution to the final step before the one you just saw, and I had a bunch of coworkers shout at me and saying, no, that's all bad, but I'll leave that up to you. You are, I'm sure, as smart as my coworkers. So just as before, we now have this class RowSpanHelper : public base, and base is the template parameter here. But what you'll notice is that all the implementation details are gone. And how's that even possible? And why is that good? Well, it's good because now a user of this class, a client of this class, can go in and read the API just as if it was a regular class without all the implementation detail to clutter his view. And how is it possible? Well, over here, I now have my RowSpanHelper, and above it says template type name base. So just as it looked like in my implementation or in my header file. Same thing here, same thing here. And had we tried and compiled this, your compiler would spit something out that I likely wouldn't understand myself. Something along the lines of, I don't know, a RowSpanHelper QTableView : disconnect span signals. I couldn't find that, and so on. And for that, I need to declare them here in the CPP file. So in the CPP file, I need to say there is this template void RowSpanHelper QListView : set RowSpan enabled, and RowSpan QListView, and so on, and also for the QTableView. That's what I have this small macro to help me with. I like this, as I said, because the client have a much easier header file to read than before. The disadvantage, of course, is that if I ever want to have a new class in here, say a Jesper view, then I would need to open this CPP file and add it here. And that, of course, works for me because I'm an application developer. It is easy for me to open this file and add a line. But if I were a library developer, say if I was working on Qt, I couldn't use this trick, because using Qt, you wouldn't like if you needed to go and actually edit the source files inside of Qt, because that would require that you compile your own Qt. But as an application developer, it is just opening this file, adding a new line, and I'm done with it. And I gained this header file that is much more readable. Thank you very much for watching this episode of Qt Widgets and More. And with just 15 minutes of your time, you now own the right to have a drop-in replacement for QTableView and QTreeView that supports these inline headers. All you need to do is to set or call that method of set RowSpan enabled, and you need in your models to return true for those rows where it is when the model is being asked with a specific role. But the details on how you implement that model, go and look at the previous episode on the RowSpan headers. I'm Jesper Pedersen from QTab. Thank you for watching. I already said that, didn't I? So until next time, have a great time.